Linear cost functions are applications of linear equations. Fixed costs don't change, they're constant. But variable costs do change. If we add fixed costs plus variable costs, they add up to the total cost. Let's see how this applies to linear equations. Say a vehicle you need is rented for $250 plus $1 per mile driven. What is the fixed cost and what is the variable cost? So that base amount that you have to pay in order to borrow the vehicle, the $250, that's the fixed cost. You have to pay that no matter what, and it's a one-time fee. The variable cost, on the other hand, is $1 per mile. But what we'll do in order to figure out how much money it ends up being is we'll actually multiply that $1 per mile times the number of miles driven. So here x is a variable representing the number of miles driven. Okay. Now we want to write a function which gives us the total cost as a function of miles driven. So we're going to use the letter C for that. And it's a function of x. So the input here is the number of miles driven. Now you have to pay the $250 no matter what. So that's going to definitely be part of it. But you also have to pay $1 per mile. But we wouldn't just say it's just $1, 1 plus 250. That's not enough. We have to put 1 times x. That way, if we drive 40 miles, it's $40. If we drive 100 miles, it's $100. So it's a variable cost, dependent on the value of x. Okay, now that we have that, if the decision is made to rent the vehicle and drive 40 miles, what would be the grand total cost of using the vehicle? So there, we'll be looking for C of 40. Basically, let x equal 40. That's what we're doing here. So you put parentheses where the x variable was, and you put in its place 40. Add them up. You get $290. A lot of times in math we can leave the units off and just assume they're there. We could put them in at the end. That's kind of common. Let's say the rental car is borrowed for $200 per week plus 25 cents per mile. How many miles could you travel if you had $375 to spend? Okay, let's start with the general equation. Oops, it's 25 cents per mile. $200 rental fee. Okay, where does the $375 go now? Does it go in the x or does it go somewhere else? Sometimes it's helpful to just write down the givens and what is being asked for. So like in the problem above, they gave us x, and they basically said find c. But what is it that we're trying to find here? How many miles? They're asking us to find x. And that means we'll let c equal 375. It's the total cost now. So it's a little tougher because we're being asked to find the variable x. We'll have to do some algebra to do it. Okay, so you'll want to just subtract. Okay, we've got 175 equals 0.25x. We'll divide by 0.25. $700. X equals 700 miles. Nice. All right. So what is the marginal cost? It's the cost a company incurs when producing one additional unit. So if the cost per item is a fixed rate, then that fixed rate will be the slope of the line. Let's check out this problem. A company owning a digital tablet factory has fixed costs of $4,000 per day. For every tablet that they produce, they have to pay a variable cost of $50 per tablet. Construct a function given the total cost as a function of number of tablets that they produce. Okay. C of x will be 50 times x, that's the variable cost part, plus 4,000, that's the fixed cost part. So here, what it was saying above is that this is the slope, and this will be the intercept. But now, think about the application of that and what they stand for. The intercept represents the fixed costs, and the slope represents the variable rate, which could also be called, in this case, marginal cost. All right, this page just gives a few examples of different fixed costs and variable costs. So, one of the things you want to think about when it comes to whether a cost falls into the fixed or variable category is that fixed costs don't depend on the business activity or the volume of product that the business produces. The fixed costs stay the same no matter what. Examples would be rent. That's something that business would have to pay no matter how many tablets they make, for example. Depreciation would be losses in value of things that they own over time. Office supplies, insurance costs, advertising, payroll for salaried employees, utilities. These are things that they would have to pay for no matter what. Variable costs, on the other hand, do depend on the activity or volume of product that is made. So think about if the production increases, and how would these things change? So material costs, they would definitely go up if the factory was making more items. So that makes it a variable cost. Payroll for hourly employees, you can have more employees hired to do part-time work, especially if your production goes up. And yeah, okay, so let's take a look now at this last problem. The cost to produce 10 items is 500. The cost to produce 35 items is 1,000. If this is a linear cost function, find the cost, which means just find the function. What I'm going to do is I'm going to put these into coordinate pair form. $10, 500 and 35, 1,000. What they represent is a x1, c1, x2, c2. And we need a function of the form c of x equals mx plus b. That's our goal here, is to find that function. So 10 items cost 500. 35 items cost 1,000. Can we find the linear function that goes through these 2 points? Now if you go to Desmos, you can actually, on desmos.com here, type in those points. 10, 500, and 35, 1,000. Okay, we should be able to zoom out and find our points. Okay, there they are. We need a line that goes through these 2 points. Now if I go over here to the wrench, I can actually shrink it down some. There we go. We need a line going through them 2 points. So how do we do it? Use the slope formula first. But notice that our vertical values here are not y anymore, but c. And x2 minus x1. Okay, so our slope is going to be 1,000 minus 500 over 35 minus 10. That's 20. Now we'll go back to our function there. Plug in your slope. The next step would be to take any of those 2 coordinate pairs and use them to determine the b by plugging in the y value and the x. Okay, our b is 300. So that makes our final answer c of x equals 20x plus 300. Now, in order to verify that this is right, we can just go back to Desmos here. And let's just type that equation in. Okay. C equals 20x plus 300. Nice. It worked. So the whole goal was just to find a linear equation that really did go through those 2 points. And now we could use that linear equation to predict the cost of manufacturing other amounts of items, for example.